Hi everyone, so today we'll be learning about linked lists, and our curriculum is going to be what is a linked list and what properties the linked list has, both conceptually and application-wise, and a little bit of both, and how do you add and delete elements, and going over iterators specifically in Java, and what generic typing is. And for just like throughout the lecture, I'm just going to call linked list as LL, just so that I don't have to write out the entire thing. So we're going to go over the properties of the linked list, and then we're going to go over conceptual, and then I'm going to differentiate between conceptual and like application / coding wise, just because an application, it won't be as applicable with like the conceptual stuff, but it's also still important to know. So the general properties of a linked list is that you can add and delete elements within a linked list, whereas you couldn't do that in an array. So you have dynamic sizing that you could do. However, you still have to have elements of the same exact type, just kind of like an array. However, you have to use generic types, and we'll go over what generic typing means later on, but this is a little different from what you would do in an array. Now for conceptual, this is just like a list, but what we're going to do is create a diagram after we go over this. Is that linked list in general is basically a series of nodes that are linked together. So linked list is still like a sequence of elements that you can use in order to access each element, much like an array, except you have to think of them as individual nodes that'll be linked together, and I'll draw that out. It's going to have these fields, you could say, these properties, that is next and previous, and it's going to have a head and a tail, and head basically means like the very first node in the entire list, and tail means the very last node in the entire list. So first we're going to draw out a node. So how I'm going to usually draw out a node is this small little box here. So this is a node. And within the node, there are like 3 properties happening. So I'm gonna divide it up into 3 little boxes. This is going to represent the previous. And then this box is going to represent the data. And the last box is going to represent the next property. And I'll explain what previous and next exactly does once we create an entire linked list. But like we said, linked list is a series of nodes that are linked together. So one node will be represented like this. And so one node will always keep one data. So if we wanted to keep a series of integers, this might just hold 1, for example. So now we're going to create the linked list, and as we went over in the conceptual side, we said linked list is a series of nodes that are linked together. Right now we've only created one node here. So let's say you have a variable called L1, and let's say in your program you actually created a linked list. So conceptually what's going to happen is you're going to be pointing at some linked list that we're going to create here. And let's say you wanted to create a linked list of type integer. So we said it's a series of nodes, so let's just draw out our nodes first. And as we went over, the first box here is going to be previous, the middle is the data, and the third box is going to be the next. And so this next box is going to be very important. Essentially, the pointer for this next property here is going to point to the next node. You do the same exact thing here. The next here within this node is going to point to the next node. Now we do the same exact thing for previous. So in the previous, it's going to point to the previous node. Once again here, we're going to be pointing to the previous node. And I want you to note that we're not going to actually draw out the fact that the previous is like null here, like there's nothing here. We're not going to draw this out just because it's going to be, messy in terms of drawing. But if you were to do the first element, the first node dot previous, it would just return null because there's nothing there. And if you were to have done last node dot next, it would also be null. So, and this part comes pretty handy. Instead of calling it the first node and the last node, we're going to call this the head. And we're going to call this the tail. So now we're going to just fill in the data types, or the data. So we said it's going to be an integer, so I'm just going to put in 1, 2, 3. And so here's our full drawing of a linked list, just a basic idea. Now to really practice what the previous and the next exactly means conceptually, I'm going to write a little bit of pseudocode here.
And then that's saved into your
So we
file.
called linked list to be, or L1 to be a linked list. So let's just kind of initialize that, you could say. So if I were to say that, if I were to want to print list1 dot next, as we said, here L1 is always going to be pointing to the head of the list, so it's going to be pointing to this first one. So we say L1 dot next, so we're going to go into the next here, so L1 dot next, let me do that again. You got L1, when I say dot, I'm going to go to this arrow, dot next. So L1 dot next. So the next is now, my finger's pointing at the next node, and because I don't want just the node back, I want the actual data back, I'm actually gonna say dot data. So L1 dot next dot data is going to be 2. So print would actually give 2. Now if I wanted to get this node right here, this node's data right here, and let's say I was not allowed to use tail. Let's say I don't have access to head or tail, and you only had access to L1. What you would do is L1, so we're pointing to this first one, dot next, dot next, dot data. So now you're at 3. So if we were to actually write that out, if we wanted to print the data of that, it would be L1 dot next dot data, which will give us 3. Now this is a little redundant to be like L1 dot next dot next dot next dot next over and over again. Instead of doing that, what we could possibly do is, before we actually talk about redundancy, I want to talk about how you can create pointers. Instead of having L1 always point at the head here, we can actually move it so that L1 can point here. I'm going to show you how to do that right now. So you just have L1, which is pointing to this first node right here. Our goal is to make it so that it points to the second one right here. Is to just reassign it. You just say L1 dot next. And so let me just get rid of this and see if you have this and you just ran this code, L1 dot next. It's no longer pointing to the head. Now it's going to point to the second node. Now let's say I wanted to let it point to the tail, the last one, and let's say I didn't have access to tail or head. All you do is dot next, and this is only gonna work if it was like this. So if you had L1 starting at the head again, and you wanted it to be reassigned to be pointing at the last node, you would do L1 dot next, so you're currently at this node, and you're assigning that value, or assigning that node to this variable called L1. So now you're moving the L1 to be here. Now, in real life, you don't actually want to do that. That means you don't have access to any of this, and it's just going to get inconvenient. What I would say is create another variable to actually keep track of which node you want to have access to. But this is just an example. That's how you would do it. I'm just going to delete this line of pseudocode now. And I'm going to show you how you would do that with previous. It's basically the same thing. So I'm just going to create another variable. I'm I'm gonna call it node, like C for current node is equal to. I'm gonna let it equal to the second node right here, so I'm just gonna say L1.next. Oh, yep. C node. So now we have C node pointing here. What I wanna do is I wanna print this node right here. You can just say L1.head or something. You can print from L1's perspective, but let's say you want to print using C node. So all you would have to do is try to get to this node, which is just C node dot previous dot data. So it's C node arrows dot previous dot data. So if we were to write that, it would be C node dot previous dot data. And this would print 1. Awesome. So now we're going to be talking about how to add elements to the end of the list. And I'm going to do this pseudocode / drawing wise to show you what's happening behind the scenes. And let's say you wanted to add the data 4 to here. So what you wanted to do is you want to add this extra node that has a data of 4, and you want this to, link together.
Because that's just how you make.
That's what we wanted to do, but we don't have that right now.
Right. And no, go ahead.
Okay. So basically, this is a lot of like changing the pointers around, changing the arrows around is what's happening here. So like you gotta change arrows. It's like the premise of adding and deleting elements in general. So for this one, we're just gonna do it to the end of the list. So because we want this another node here of data 4, what we need to do is to have it so that you see how it has dot next pointing to the next node, dot next pointing to the next node. What we need to do is link the node 3 to node 4. And the only way you're going to be able to do that is so that if node 3's dot next is pointing to node 4, and if node 4's previous here, dot previous, is pointing back to node 3. It makes sense because node 3 dot next has to be node 4, and node 4 dot previous, the only previous node you have to see is 3 right here. And so in order to do this is, let's say you created node equals like node 4. This is all pseudocode. This is not an actual class in Java. But let's say you created this. So I'm gonna call it node 4. And so node 4 is referring to this node right here. It's kind of floating around right now. And you have list 1, L1, that's pointing to the list of 3 elements right now. Now let's say that you don't have access to head or tail. The only way you're able to access these elements is if you were to say L1.next. That's the only way that you can do it. So in order to do that, let's say, so first you want to be able to access the third or the current last element right now. And we kind of saw it in the previous example. Let's call this last node. In order to get here, you need to say last node is equal to L1.next. So now you're here, so it's going to be L1.next. Now this guy is actually pointing to this node. Perfect. Now that we have that, and we have node 4 right here, which is just floating around, this arrow still doesn't exist. So what we wanted to do is last node dot next. So we're saying that last node dot next, we're going to create that arrow right now. So last node dot next is equal to node 4. So this is basically saying the next node after the last node needs to be node 4. And the notation right now that I'm using is last node dot next. Last node dot next is going to be 4. So now we've created that arrow. Now what we need to do is have it so that node 4's previous is going to be pointing to node 3. And it's like the general same idea. So you say node 4 dot previous. So node 4 dot previous is equal to last node. And last node we know is pointing to this node right here. So node 4 dot previous is equal to last node, just created this link right here. So you've added another element to the end of the list. And if you want to be a little more nitpicky about it, and like we said, the end of the node here, the dot next is always going to be null. So you could even say node 4 dot next. Node 4 dot next, this box right here, is going to be null. Okay, so now we're going to be talking about how you can delete an element from the end of the list. So what we want to do now is get rid of this 4, and the last node has to be 3. So what we want to have the original one back, which is, we wanted to make it look like this. But right now, we currently have a list of 4 elements with the last node having a data 4. Okay. So it's going to be the same idea as we did with adding a node or adding another element to the end of the list. First, you're trying to change the arrows around, basically. And to do this is so that this node 3, the next one shouldn't be pointing to another node. Like we said, the last node in the list, the next here, will always have to point to null. So all we have to do is make it so that, let's call this last node, like last node as in this is what we want the last node to be. In order to get here, you would just say last node is equal to L1 dot next, dot next, so L1 dot next, dot next. So now we're here.
So this is the underline is the original that's from the list. And then
So we said the next part here for the node 3, where the last node needs to be null.
So you're jumping to the next.
So now it's null. What's gonna happen here is gonna point here. There's nothing there, so it's going to be pointing to something that's not any node. And if I'm sloppy, I'm just gonna leave it like this, but I don't want this arrow to be pointing back to this node. So to be even more fancy, I think what we could have done before we made this change is we could have said node 4. So if we were to run this again, line by line, if we still have this, so I'm doing, so last node is equal to this right now. And let's say we have another pointer here, and that would just be last node
or
dot next. So we have last node dot next, which is node 4, and we're putting that in a variable called node 4. So we have another pointer called node 4. Now we are looking at this line of code, which is saying last node dot next is going to point to null. So we get rid of this arrow, and now it's pointing to something that's not there. Now what we want to do is get rid of this arrow. So in order to get rid of that arrow, we will just call it node 4
Is it working? Yeah.
dot previous
So yeah, because like first I only had this, and then it was giving
is
me an error.
equal
And then
to
Because
null.
so you're moving to here.
So now
And then
this arrow is gone, and now you have a lone
And then you add a node, but you never move
node
back.
here.
So if you say
And
previous
you could say in Java they have this like garbage collection where it's like if this guy's not doing anything, then Java's immediately just gonna get rid of it. So you don't even have to worry about actually destroying this object. You can just make the pointers not point at this node, and it'll immediately be so that it'll just look like this. So you don't have to ever worry about that node at all. Okay, so now we're gonna talk a little more about like how concepts don't exactly translate into application/code form. So when you're actually using Java in order to use a linked list, what we talked about, like head and tail, next and previous, all the stuff that we did before, you actually technically don't do it with a linked list in Java. So like none of this really exists, except for next and previous, which is living inside the list iterator, which we'll talk about in the next section. But like none of this actually exists when you're applying linked list in in Java. And the reason why you still need to know it is because it's good for debugging processes. And it's also really good to know because that's probably how the Java developer created linked list. So he or she probably used nodes, .next, and head and tail. Probably used all of those properties in order to create the linked list as user-friendly as possible. It's just that you as a programmer using Java don't have access to any of those information. So you could kind of think of using linked lists in Java as like the user-friendly way instead of having to get each node yourself. And the reason why it's actually easier is if you go to JavaDoc, which I highly recommend that you do, is that you can use remove I think. This means like you're putting in an index number for the linked list, and you're so like if you wanted to get rid of the third element, then you would say remove the third element from that list, so you don't have to do the whole pointer thing yourself. Or I think they also provide, like if you have a data, you might also be able to just say if you have like an element with a data called 3, then you can remove that node that has that data 3. I'm not sure if that's true, but like there is something like that so that you don't have to iterate it through it yourself, but you actually can. And some other side note is that in arrays you would say array.length to get the length of the array. If you wanted to get the length of the list, then you would say L1.size, and this will give you the length of the linked list. However, there's a lot of very useful methods that you could use in linked lists that you didn't have to code for yourself, so I really recommend looking through the JavaDoc. Now we're going to be talking about list iterators. So that's the stuff that's very similar to the conceptual things that we did with the whole L1.next, .previous. That is the most closely aligned to list iterators. So first I'm going to show you how to declare and initialize one, and I'll show you how you can use it in your program. So first you declare list iterator, and you also declare the type. So the type here is not node. The type here is like the data type that it's talking about of each element. So here, if this is each node, we're talking about the data type of the actual data, which is integer here, so I'm going to call it an integer. And I'm just going to call this iter for short for a variable. And what you do is it's L1, which is the linked list that we created, L1.list iterator, parentheses, semicolon. So you're pulling this method out of the linked list class, which is why you say L1.list iterator. I want you to also notice that even though you capitalize the L in list here, you do not do so here. So that's like a small little thing. And here, it seems like I was checking JavaDoc, you have to declare the data type of each element here, but I don't think you have to do one here, but try it out yourself and see if you get that excellent warning. And another thing is, so what's happening is, since you've created this iterator called iter, if you have a drawing called, or the drawing of L1 here, you have a pointer called iter here pointing to the head of the list. If you wanted to point to the tail of the list, so if you wanted iter to be pointing to the last node, inside the parameters, you would call size of L1, so you would say L1.size. And this essentially is going to have iter point to the last node of the entire list. But we're not going to do that. We're just going to start from the beginning. So let's just keep it like this. So now we have iter pointing here. So the top two properties that you'll be using probably the most is going to be iter.next I think this is a method. Check JavaDoc is what I have to say. Iter.previous. These are the most commonly used methods within the list iterator. And so we talked about how so if in the pseudocode what we had is L1.next. And so L1.next would just return that node. However, and if you wanted to return the data, then you would say .data for like pseudocode wise. So iter.next basically does this entire operation right here. So iter.next is not going to return the node itself, it's going to return the data of that node. So iter.next is going to be here, so iter is pointing here, so it's going to point to the next node now. And it's going to be specifically pointing to the data, so this will return 2. Now that iter is here, if we wanted to do iter.previous and get the element there, we're going to go to the previous node, so iter.previous, and the data there is 1. So that's basically what iterators are. And you're gonna have to probably use it in one of the homework assignments for the semester. And another way of looking at it, instead of having to always draw this out, which is kind of tedious, is if you just have a linked list with these elements. I just draw these small little carets, and these carets represent where the iterator can stay. So when you first initialized iter would be here. But if you said iter.next, then iter would now be here. So I just moved it here. And this caret is going to be basically returning the element 1. And let's say you did iter.next again. Now iter is here. So now it's going to return 2. And let's say that you wanted the previous element again. So now this is like the caveat of it all. If you did iter.previous, which is different from like what we did here. If you did iter.previous, so you would go here, so now iter is here. It's not going to return 1, it's going to return 2. So it's returning 2 twice. When iter was here and you did iter.next, it returned 2. When iter was here and you did iter.previous, now that you're here, it's still returning 2. And so that's a very powerful like illustration that you could draw for yourself if you're using iterators and it's just not iterating over what you wanted to iterate over. So make sure you draw yourself a simple picture like this. Okay, so now we're going to be talking about generics, generic types specifically, and I've been talking about them throughout the entire video. And generic type is basically meaning you're changing a primitive data type to a reference type. And if you don't know what primitive and reference means, I'm going to do a little diagram afterwards. And when you're looking at Java docs, they're always going to be denoted by angle bracket E, angle bracket. This means that this constructor or method or whatever it is, it's always going to be taking in a generic type. And you'll also see it in the linked lists on Java doc. So if you have linked list, like let's say you're in a Java doc, it'll be always denoted by E. And this basically means the element type needs to be a generic type of an integer or a float or something like that. So anytime you see this, that means you're taking in a generic type. However, if you see like angle bracket V or something, or angle bracket A, they all mean the same thing. All the letters itself don't really matter. It's the matter of fact that you have an angle bracket, some letter, another angle bracket. That just means that you have to put in a generic type in. But we're going to keep it as E just for conventionality. And so here's all of the keywords that you would usually use for primitive data types. So if you were to create an array, you usually have to say int in like square brackets or something like that. So you had int, lowercase double, char, float, and bool. Now, if we were to translate that into generic typing, it's very easy. All you have to do is, instead of saying just int, you have to actually capitalize the I and write out the entire integer. For double, you just capitalize the D here and it's double. char, capitalize C, and then you say character. Basically the same exact thing. String is technically not generic type because it's already a reference type, so it's not like you have to change string to a reference type because already it is. So I'm just gonna say, like, I'm not gonna put it on the list, but you can create a linked list of strings. But that's basically what it is. This is how you would use it, and that's why when you saw in previous examples when I was declaring a linked list or initializing a linked list, you saw me do angle bracket integer instead of saying angle bracket int. This will throw an error in compiling when you're compiling anything. So when we're talking about primitives, so if you have a stack and heap, so stack is a fancy word that I'm going to use, but basically let's say you just have a main function here, and let's say you're declaring or you're initializing an integer x, so this is just a variable, and you want it to store number 1, for example. So you would just store it within the main function part. Heap, remember, is going to be where you're storing all the reference types, so where all the arrows and pointers happen. So let's say you have some generic integer, and let's just call this y. And so even though y is of type integer, you would think that you would store, like let's say 2 within the main function. In actuality, because this is a generic integer, meaning it's now going to be a reference type, you're actually going to point within the heap the 2. So primitive is nice because it's like nice and fast. You just kind of store that inside the main function here. Whereas with generic / reference types, you have to actually create a pointer to the heap for dynamic memory processing. And so that's basically what generic is. So if you come across any other data structures other than linked list, you will have to keep using generic typing. So make sure that you keep this in mind specifically for Java.